Hello everyone, welcome to part 2 of our merge sort example. Right, so when we left off, we talked about the merge sort function, and we kind of hand-waved the implementation of merge. And here in this video, we're going to cover that. So here in this highlighted red box, we're at the stage where at this section is going to call the merge function. And it has 4 arguments: a vector, which contains data, whether it be integers, strings, floats, whatever. Then we have our left index, our middle index, and our right index to merge everything. Right, so here's how it starts. We create 3 integers, I, j, and k. We have a left size and a right size to determine the left side that we're going to merge and the right side that we're going to merge. In this case, they're both 1 because we only have 2 values there. So create 2 additional vectors, which are going to be copies of the master vector, which is on top, and we reserve the size that we need. In this case, it's simplified. We just need 1, and we fill in those values of the left and right vector. Right, so the idea in general is that we take copies. So we have the left side and the right side that we take copies of. So the second half of merge is now continued. We set I, j, and k to its values, and we enter a while loop. So while the left side I, which in this case is 0, is less than the left size being 1, and j, which is 0, accessing the first element of our right side index vector, is less than the right size. While this is true, in this case it is, we're going to keep adding the in-betweens of merging. And we do that here. So in this case, j is less than I, right? So right vector of j is less than I. So we call this else function inside of the, we go to the else statement in this while loop where vect k, which is 0, is now assigned right vector of j, right? So 18 gets stored there. We increment j, we increment k, but hold on. Now j is incremented, j is 1. 1 is not less than 1. So we break out of the while loop. And we have these 2 cleanup while loops down here where we clean up either the right side or the left side of the array and store it everywhere. Here in this case, it's simple. The second while loop is called the I less than left size while loop. And we store I into our merged vector, and that's it. So this third while loop's never called because that's what breaks it out of the first while loop in the first place. So now we finish that merge function call, and we go to the next merge function call. The next merge function call is called by the segment that's highlighted in the red box, and the green box is just what has been merged. Right, this is what has just been merged, and now it's sorted. So now we take this green box, which is the 18 and 57, and merge it with the 25. This is what happens. So we take the left side, which is the 18 and 57 array, we make a copy of it, and we take the right side of the array, which is just 25. Here it's nice and simple. Right, so now we'll merge it and sort it together. So we enter our first while loop, and we look at the if statement. If left vector of I is less than right vector of j. In this case, this is true. So we say vect of k is equal to left vect of I, which in this case is 0. So then we increment I, right? So now we're still in that while loop because I is less than left size, and j is less than right size. So we look at this if statement again. Is left vect of I less than right vect of j? No. 25 is less than 57. So we trigger the else statement inside of the first while loop. Vect of k is equal to right vect of j. And we increment j. And this is what it'll look like. But now j is out. So we're no longer in the first while loop because j is equal to right size, and our while loop that checks both I and j is now incorrect. So we go to our second while loop and we check. Well, if is I less than left size? Yes, it is. So then we store vect of k, we store left vect of I inside vect of k. Right? We increment I and k. And then if we move I, well, j is already greater than right size, so we don't trigger the third while loop at all. Right, so now what's in the green box has just been sorted. We've just finished sorting that, merging it. So now we've separated the right area of this vector, and in the red box is now what we're going to merge. Okay, so here's how we go. Here's how it goes. We create a copy of it, and it's similar to the 57 and 18 example because it's just two elements. We take two copies of these elements and we put them in their own arrays. It's a little simplified because, well, it's just one element in each array. Then we go to our second part of merge, where we enter that while loop. So while I is less than left size and j is less than right size. Both of these are true, so we enter the while loop. So we check if left vect of I is less than right vect of j. This is true, so we store left vect of I into our vector, where k is, and wait a minute, that's it. I gets incremented, and now it's greater than left size. So then we check into our second while loop, while I is less than left size. Well, it's already greater than it, so we don't execute anything in there. So what's left? Well, j. J is still less than right size. So we assign j to vector, where it is. Right, so that segment of that array is now sorted, and which is coincidental because it's already sorted. But now we're at the top. Now we're going to be merging our size 3 sorted vector of 18, 25, and 57. We're going to merge it with our size 2 vector that's highlighted in the green box of 6 and 12. Right, those two are going to be merged together, and it's called by the array at the top highlighted in the red box. So how will that work? Well, we need to take copies of the left side, which is 18, 25, and 57, and a copy of the right side, which is 6 and 12. And we're going to go through our while loops. So here we're going to compare, we're going to check if I is less than left size, which is true, and j is less than right size. This is true. So if left vector of I is less than right vector of j. Let's check that out. Is this true? No, because 6, which is right vector of j, is less than left vector of I, which is 18. So we execute the else statement inside of the first while loop, and we say, okay, vect of k is equal to right vect of j. Then we increment j. And we're still in that while loop because j is less than right size and I is less than left size. So we check our while loop. Is left vect of I less than right vect of j? No. This is not true. So we trigger the else statement inside of the while loop. Vect of k is going to be equal to right vect of j. Well, shoot. Now j is equal to right size. So we break out of the first while loop and we go to the second while loop. So while I is less than left size. Is this true? Yes. So we store left vect of I inside of vect of k, and we keep incrementing. Well, this is still true, so we increment and we store that there. After this, I will increment and it'll be greater than left size. So let's check our third while loop. Is j less than right size? No, it's actually equal to right size. So we'll skip that while loop in total, entirely. Right, but notice now, if you take a look at the vector, it's sorted. Thank you.